Hello and welcome to this week's tutorial. We will create this pixel art loading animation that you see on screen right now. So let's begin. Okay, first of all, of course, we delete the default cube. Let's add in a cylinder. And if we go to side view and switch to X-ray mode, at least that's what I'm calling it, you can give this some edge loops like this. And now we want to use proportional editing to modify this, all right? So you can either just click this button or just hit O. So you use the shortcut, you know, really fancy. And we want to switch the method from smooth to sharp, okay? Like this. And now you can see we already have something that really looks like the bottom of an hourglass, really. So we can just stop right here and we can delete the bottom part. We don't need that, like this part. So this is a good base. Now we just select the top part and we extrude, okay? Like this. You want to add some edge loops again, maybe like 5 or something. And we do the same thing. We select the top part and now we switch the method again. We switch it to sphere. And you want to lower your proportional editing radius. And now if you scale in, you get this like this curve, which is really nice, which is what we want. Okay, so we bring this up. And now we want to apply a mirror modifier to this. So go to the modifier stack and then select mirror and put the axes to Z. Now you can see they intersect, which is never good. So switch to edit mode, select everything with A, bring it down. And then you want to enable clipping. So when they touch, they merge like this. Okay, great. So now we have this. Let's view this in the solid mode. You can see there are a couple of problems. So first of all, we have to close the bottom part. So let's do that. Switch to wireframe again. Select the bottom part, hit F. Now it should be closed at the top as well. And another thing is that in the middle of this, because we used a cylinder originally to create this, it's closed, which is not good. So select the face and delete it. Now you can shade auto smooth, and that's that's the base for our hourglass. One last thing is to we want to extrude the bottom part. So you want to switch to face mode and you click on the edge to select, I don't know how to call it. You know what I mean. You make it like a circular selection of the faces, right? And then you hit E and S to extrude. And you do the same thing on the bottom part. So select the edge and you extrude it down. And now you select the edge again, like this, and you extrude it outwards with E and S. Great. And now we have this, which really looks like a pretty solid hourglass model, I think. And you can further customize this, of course, if you want to really go, like, you know, like if you really want to go in detail, you can select the whole edge and you can bevel it, you know. You can get a little bit creative with this. To me, this is fine. I think this works. In order to fill this hourglass with sand, we will use a rigid body simulation. And why do we do that and not just use liquid simulation? Because liquid simulation can be really buggy, and when you use liquid simulation combined with a moving object, it just breaks and it just doesn't work. So we will use a rigid body simulation to fake the liquid. First of all, we want to select the hourglass and we go to physics properties and hit rigid body, and we put that to passive. Also, the collision shape, we put that to mesh. And don't worry, I will explain all this stuff in a second. But for now, for all the people who already know this, I'm just going to skip through this. And after that, I will explain everything. So put that to passive and mesh. And then we add in some spheres. So go to to wireframe mode, and you want to lower the size of the sphere, so the sphere is fitting through the middle part, of course, right? So I think this size is pretty good. This works. So bring it down and apply rigid body as well. Active collision shape is sphere. And now we just duplicate this a bunch of times, and we create some variation. So, scale it down, scale it up. So maybe like this, okay. I think they're still a little bit too big. So what I'm gonna do, I will select everything, like all the spheres, and I will go to this button, and I can switch it from median point to individual origins. And now Blender will they will scale down from their individual origin. So I can just scale them down. Okay. And then I put it back to median point. Now I select everything and deselect the hourglass, and I duplicate this a bunch of times so I have enough spheres in my scene, like this. And now if I play this, you can see they just fall through the floor. And why is that? Let's see. Of course, we have to apply the mirror modifier first. Okay. So now it should work. Yes. Okay. Okay, great. Next step, select everything again, deselect the hourglass, and when they are on the floor, right? You want to hit F3 and type in a visual transform, and this will apply the visual transform. So what we see right now, they will start in that position. So here's a quick lesson for a rigid body simulation when it comes to the collision shape. What is a rigid body simulation? Basically, when you apply a rigid body simulation to an object, in our case, it's the spheres, right? And the hourglass. You basically apply physics to that object, right? The object will then move through space in a physical, accurate way. The object will collide with stuff and it will bounce off stuff. Therefore, you have active rigid body objects which move, right? Our spheres, for example. And then you have passive rigid body objects which act as an obstacle, right? So they don't move except when they're animated, like our hourglass, for example. But they don't move through space. They're kind of like static, right? But when it comes to the collision shape, for example, when I take this Suzanne monkey, you can see I have different versions of this, right? I have one version where it's a sphere, and I have a cube around the monkey, and then there's a convex hole, and then I have one version where there's only the monkey. So what does this even mean? Like, why do I show you this? Basically, if you would go to this monkey and you go to the physics properties and you apply a rigid body simulation, you can see down here in the collision tab, you have this thing called shape, okay? And here I basically can select how Blender will kind of like look at my object when it comes to collisions, right? For example, if I take sphere for this monkey, Blender will treat this monkey when it comes to collisions as if it was a sphere, right? So basically Blender is applying like an invisible boundary around the monkey. In this case, it's a sphere, so it would look like this if you would see the boundary. If you would select, like a box, it would look like this. And if you would select a convex hole, it would look like this. But of course, when it comes to a monkey, right, if you want like physical, accurate collisions for your monkey, you wouldn't select any of these because like this doesn't make any sense. You would select another option which is called mesh, because we have a complex geometry in a way because it's modeled, right? It's not a basic shape, it's more complex than that. So we choose mesh for that. And then Blender will say, okay, I'll look at the model and I will apply a boundary that is like accurate to that model. And that way we make sure that Blender is actually taking the model into account and we have correct collisions. So in which case would you choose like these boundaries for like a complex shape like a Suzanne monkey? You know, maybe if you have, let's say you have a bunch of monkey heads in the background and they fall to the ground, but it's really just in the background and it's like out of focus or something, and you really have it only because of like visual noise, then you can apply something like box or sphere, because it's not even the focal element, right? You can't really, you won't even notice it. You won't even notice that it's not like physical accurate collisions, right? So that would be a case where you could use something like this as a collision shape for this type of model, okay? Now we can just duplicate this again, like maybe like 3 times. And I think now if we play this back, I think now we have enough geometry to play with. Another thing that I'm seeing right now is that if we go inside of our hourglass, we can see that we have here, like, there's no face here, right? So the spheres, they can like fall down in this like bottom area, and we don't want that. So an easy way to fix that is to go into edit mode, go to vertex select mode, and if you hit alt on the edge, you can select the whole row of vertices or whatever. And you do the same thing on the bottom by hitting shift alt. If you go to F3 again and you type in bridge edge loops, bridge edge loops, and that way we can close the hole, right? And we do the same thing in the top part as well, by the way. So, you know, just go up. So in this case it's here, and the other one is here, and I do the same thing, bridge edge loops. There we go. Now it's closed and we are fine. Great. Okay. So let's see what this looks like. Okay, so for some reason it deleted the bottom part. I don't know why. I'm sorry. Is it, yeah, on the top side as well. Okay, I don't know. I don't know what happened. Just fill in the faces if this happens to you. Okay. So let's play it back. Now there we go. Okay, great. Actually, let me select the top like bunch of the top pack of spheres, and just put it to the side a little bit like this. And let's do the same thing for the bottom ones, because if they are on the same position, they have a hard time to like flatten out on the bottom, and this has to happen fairly quickly, right? In order so we can like actually start with the animation. So this is fine. I don't know, it's really, to me, it's really tempting to just apply this again and then duplicate it again so we have more. Yeah, let's do that. Okay, if your PC can't handle this, don't do it. But I will do it. Apply the visual transform again. Visual transform like this. There we go. And now we can go to the first frame, duplicate it, bring it up. There we go. Let's go to frame 60. And let's begin with the rotation of the hourglass. If you click the hourglass and you go to item, we can see that we can just keyframe it here. So I'm just gonna hit I on the X. If you can't see the bar that I just worked with, it's because you have to like click on your object and then you hit N, and that way the bar will show up. And skip to frame 90 and then just put in 180 and keyframe this. And now it should work. Yes, let's go. On the hourglass, we have to check animated. It takes the rotation into account when it comes to the rigid body simulation, and we are fine. And we will see the next problem right away, which is, oh, okay, it works. Right off the box. That's weird. That's weird. Okay, so if your spheres have a hard time passing through this hole, don't you worry, because you can just click on the hourglass and you go to surface response. And here you can set the friction, which is kind of like how smooth the surface of your hourglass is, right? Like if I put this to 0, you will see that all the spheres, they are kind of like it's like kind of like they're on ice, right? Like they're really like sliding around and everything. So if your spheres have a hard time passing through, just lower the friction, and they will just pass through. I think this just works every time. So just put this to 0 or whatever. In my case, 0.5 worked, which is which I like more than 0, because now they don't spin as much. But yeah, you can just play around with this number till you get something that works for you. So on frame 240, I will put the next rotation keyframe. So I'm putting I rotation. So Blender is resting in this position for this amount of frames, you know, from here to here. And I put the max scene size when it comes to the timeline to maybe 500 frames, okay. And remember, for the first rotation, it was 30 frames. So I will do the same thing here. Put this to 270 and rotate this thing 180 degrees again. So what I'm gonna do, I will go into the rotation here again in this parameter, and I will put plus 180. And that way I make sure that Blender is not messing the rotation up or doing something weird. I'm just getting the result I want. So now we have another problem. If we play this back, we will see that Blender is stopping the rigid body simulation at frame 250. And the reason is, if you go to scene properties and go to rigid body world, you can see if you go to cache that by default, Blender is setting the duration of your rigid body simulation to 1 till 250. And we don't want that. We want, in my case, 500 frames. In your case, maybe something different. If your PC has a hard time just playing this back right out of the box, you can just bake this, which basically means Blender is first calculating everything and then you can play it back smoothly. Next step is to transform these spheres into actual sand, because we don't want spheres, we want sand. They kind of have to like merge with each other, and we can achieve that by using the remesh modifier, okay? So first of all, we want to select all the spheres in the scene. So just click the first one, scroll down, and with shift click, we select all the spheres, and then we hit M, new collection, and call this sand or particles or spheres, whatever, you do you. We want to create a placeholder for our geometry nodes that we use in a second. Don't worry, it's going to be really easy. I know. Geometry nodes can be really intimidating. Really important, if you create this plane, make sure that it's created on the collection and not in the sand collection, like in this collection, because we will instance this collection, and you can't instance a collection if the object that you have the geometry nodes on is in that collection, right? So what I mean is, if the plane would be in this collection, I can't instance this collection because, you know, the object is in there. So make sure that your plane or whatever you use is in another collection. Select the plane, go to geometry nodes, hit new, and you want to drag in your sand collection like this. If we go to wireframe mode, if I go to the first frame, and if I disable this, we can see that we can't see anything. And the reason is that we have to, I mean, it is there, it's just here. So the position is not correct. The reason is that this is set to original, and we have to put it to relative. If you would ask me why this is happening, why do we have to press relative, I think it's because Blender is just saying, okay, put these spheres relative to the position of the sand collection, and if you put it to original, it's just putting it in the like location of the plane. That's my understanding of this. But if you want to know it in detail, you can just hover over this or just do your research. But I think that's how it works. Okay. Another problem is that if we look at the data right now, I mean, we can see the spheres, but we don't really have data. So right here on the left side, you can see there's nothing there. We have no edges, no faces, no like vertices. And if I would go to the modifier stack and apply my remesh modifier now, you can see nothing really happens. And the reason is that we first have to kind of like realize these spheres, okay? So they actually have some geometry, right? So we separate the children first. So now Blender is actually recognizing these spheres as separated objects. So now we have actual like 288 spheres here. And now we have to realize them, okay? And now we actually have data and attributes and position and everything. And now our remesh modifier is working as well. So that's great. You can play around with the voxel size. If you go lower, you will get back more detail, but it's gonna be more render intensive. So for me, 0.03 is the number of choice. Maybe 0.04. You know, it should look like sand, right? It should not look like spheres. 0.04 is fine, I guess. This is a really good point to save your project, so I'm just gonna do that. Now we will add in the particles that like float around the hourglass. So we will do that by just adding in the collection. We will add in a torus. And we put that in the middle of the hourglass, scale it up a little bit like this. And now we can apply a particle system. And we put the source from like emit from to volume, because we want the particles to emit from the volume, right? We want to put the start and end frame to 1. Why do we do that? So now all the particles spawn right away. They don't spawn after time, they are right away in our scene and we can work with them. Great. The lifetime, we want to put that to 500 so they don't just disappear, they stay the whole like duration of the scene. Also we go to field weights and we put down gravity. And this means that there's no gravity now, they just float around. To make them spin, we will add in a force field. We will use the vortex force field. And the good thing is, I think the default settings of this thing just work. We have too much particles. So we go to the particle system again and we put down the number to like 200 maybe. Yeah, so I think this is fine for now. If we add in an ecosphere and we lower the subdivisions to 1, we can use the ecosphere for our particles. So we can go to the torus again and we go to a render and we put it from render as to object. So we basically say, hey, like for every particle that you have in your particle system, just use this ecosphere, right? So now we have tiny ecospheres to act as our particles. We go to render and we can amp up the scale, the scale randomness. And now they actually have different like sizes and everything. And also you can change the overall scale here, like the average scale of the particles. And if you don't want to see the torus, which is reasonable, you can go to the render and you can disable the show emitter, so your emitter won't be shown in the final render. But if you don't want to see it in the viewport as well, you go to viewport display and disable it here as well. Another thing I want to add in is the smoke, like the fog. And we will do it in a similar way. We will, first of all, let's rename the torus to a particle system, so we have some like form of organization here. If you are not happy with the distance between your particles and your hourglass, you can just change that by scaling up the particle, like the torus that is holding your particle system, right? Like for example, if I scale it really, like if I scale it down and I reset the particle system, you can see that our particles are really close to the hourglass. But if I take them and I scale the whole thing up, you can see that now they actually leave some space between the hourglass and the particle system. So yeah, just play around with that if you're not happy with the distance of things. Now let's continue with the fog. So add in another torus. Let's put it here for now. If you hit shift and right click, you can switch the position of your 3D cursor. So this will be the place where our torus is spawning from. So torus, and if I now go close and I amp up the major segments to maybe like 100 times 100. I think that's enough geometry. And we shade smooth. We can use this torus to create the fog from. So first of all, we go to the modifier stack and we add in a new geometry nodes. Let's think about this for a second. We want some fog, right? And first of all, we need to displace this torus so it's actually looking like fog, okay? So when you're displacing something in geometry nodes, you kind of like take the existing points of your object and you move them, right? You distort them. So that's what we do. We say, okay, take the points of the torus and then please distort the position of the points. So we use a set position, okay? So in order to distort this torus, we will use a noise texture and we put it to, like if I just plug this in, you can see that our torus is actually like it's moving away from the original position. So we can fix that by adding in a math node, and we put it to subtract, and you just put it to 0.5, and now everything. Actually, let me do that again. Vector math this time. Subtract and then 0.5. Okay. Okay, so if we lower the scale, we can see that we get something more like what we want basically. And if you so this is looking like more organic, and if we bring down the roughness as well, it's really organic. And if we go to 40, we now have this W slider that we can animate. So now you can see we really have something that kind of looks like, it could be fog. I mean, it's a good base for fog, right? So let's use that. If you add in a set material node after you set position and you go to the material section and you hit new, and we call this fog, we can use this material for our torus. Because in geometry nodes, you can't just apply a material, you always have to use a set material node and then select your material. So in our case, fog. Okay, cool. So let's preview this in render mode. This is a good time to switch to cycles as well and put it to GPU compute. Now we go to material, like shader editor, and you can see this is the fog material right now. So we want fog, right? So we first of all, we go to the top right corner to enable the default HDRI of Blender. So we delete the principled volume and we add in a principled volume. And we can play around with this by, like on the density, we just use a noise texture. So now if I plug in the color ramp and I play around with these handles, you can see we now actually get something that looks like fog. How does this even work? Why does this even happen, right? Basically, if we preview this, you can see this is how it looks when we just view this as a color, right? Basically, what we say is, hey, Blender, everything that is black, there's no volume, and everything that is white, there is volume. So if we plug it into the density, because that's what density does, right? Like we basically say, in the white area, we have this amount, and in the black area, we have this amount. And basically, white means 1 and black means 0. And that's why we get these holes. If you play around with these handles, basically it gets more and more extreme. So now we really get something like this. And you can play around with the scale of things, so you really get different results. You can take this even further. We can say, okay, we have like this one setup that is giving us this result, but we can duplicate this and put this to maybe like, I mean, this is 1.8, maybe we put this to like 7 and we plug it in. So now it looks like this, right? And we can, maybe if we switch the handles, yeah, this is better. We can combine these. So if we put this to, if we search for mix color, we can basically combine the two versions to actually have some variation. So we have like one big chunk, and then we have some area where we only have like just the small clouds from this one, right? If you play around with the factor, you also can basically say, okay, is this more dominant or is this more dominant, right? Like which one of these should be more, like more in the foreground, basically, like more dominant in a way. So you can see if I put this to 0, we only get like this one. But if I put this to 1, we only get this one. So obviously like 0.5 is like the best of two worlds, but maybe you only want actually you only want this one, but just a little bit of the other one, right? Like this. So I think this is a good amount for me. If we go back to the geometry nodes, like I said, we can play around with this. We can just animate this W slider to actually move the fog. And we can use a scene time node for that. We will use the seconds in our scene to animate this, right? So like every second in our scene that goes by is causing this torus to move. So you can see now it's animating, and you might think this is too slow, and you can modify this if you add in a math node in between. You can see that if I put this to multiply, obviously multiplied by 0.5 makes it even slower. But if I put this to 3, for example, it gets faster. So you really can play around with this. One last thing, I think this is not distorted enough. If you go to modifier and we add in a displace modifier after the geometry nodes and you click on U, we can play around with this even more. So if you add in a new texture and you click these two buttons, you actually switch to the texture section and you can add in a new texture that will be used to distort this torus. So we will use clouds. So Blender will then take this texture to displace this. And remember, this is the same thing that I explained earlier. So it will look at this noise pattern, and everything that is white will have the value of 1. So Blender will say, okay, this section has the value of 1, so I have to distort it that way. And everything that is black is like 0, so it will stay the same or will be distorted in another way, right? So we can play around with the size of this. So I will make it really big, like 2 or something. And now we also, if we go back to the modifier, we can put down the strength to maybe 2. Maybe a little bit more. Something like this. And maybe I put down the... Okay, so maybe I put down the size to... yeah, 0.5 maybe. Then I just animate this over time. So I set a keyframe with I, and I go to the last frame by hitting Shift and then the right arrow key. And I put this to maybe like 0.9, and then I hit I again. And now if we play this back, you really can see that we have something, you know, like it's morphing, it's moving, and it's really organic. Okay, and if we put this to render view, you really can see this really looks like fog now. Let's put this in the middle of our hourglass and let's scale it up. Okay, I want to animate the hourglass even more, so let's do that. We want to have the hourglass and the sand like moving in an up and down motion. So in order to achieve that, we first of all have to bake the keyframes of our rigid body simulation. So what you want to do is go to the first frame, and then in your sand collection, you select all the spheres. And now you hit F3 and you type in bake to keyframes, okay? And now you select the whole duration of your timeline and you click OK. And this can take a while, but this is necessary in order to have a seamless movement of the hourglass with the rigid body inside without any bugs or hiccups. So what we will do now, we will add in an empty plane axis, and you want to bring that up. Oh, make sure that it's not spawning inside of your sand collection. Make sure it's in your main collection, and you want to bring that up like this. Select all the spheres that you have in your sand collection. Select the first one, scroll down and select the last one with and select all of them with Shift and then left click. And then you go up to that empty that you just added in. You select it with Shift click. And now you say Control P and keep transform. Now you can see that all the spheres are connected to this empty now. And you want to do the same thing with your hourglass. So select the hourglass, select the empty, and say Control P, keep transform. And now we can use this empty to basically move the sand and the hourglass while the hourglass is spinning. So for example, if we have like this motion, right, we can also, on top of that, we can move the hourglass. So what we will do now, we will use this empty to introduce like a wave up and down motion that will be that will cycle throughout this whole animation. So on the first frame, we hit I for location, and we go we skip to frame 20 maybe, and we bring this down a little bit like this. Maybe that's too much, maybe a little bit less. Maybe like this. And you hit location again, like I and then location. And then you go to frame maybe 50 this time. Maybe we give this like 10 frames more, because now the hourglass is traveling up like this. And you hit I location. And then finally at frame 70, we bring it down to the original position. If we play this back, the hourglass should move down. Yeah, it goes up and then it goes down again. Great. The way we can loop this animation throughout the whole scene is basically you take your empty, you select any of these keyframes and you go to the graph editor, and now you want to apply the cyclic, like the cycles modifier. Okay, so basically what Blender will do, it will take your keyframes and they will just repeat, right? And now we have the same motion through the whole scene. Another thing we want to make sure is that our smoke is, like the fog, is actually spinning, because why not, right? I mean, it's cool. So let's make the fog spin. Pretty easy actually. If you go to the first frame and you open the side panel by hitting N, you can mess around with the rotation, and we can do that with a driver. So just type in hashtag frame slash maybe like 120. So now you see it's spinning on the z-axis. If you think it should be faster, you can lower the number. If, for example, if I put 30, it's gonna be faster. So maybe put something that's like equally to your particles, right? So I think 30 is actually not that bad, maybe like 40. So it's a little bit slower. Okay, so we are done with the animation. Let's give this some materials, give this some lighting, and let's wrap this up. So first of all, you want to go to your world settings and you want to put that to pitch black, okay? After that, we can create the hourglass materials. So select your hourglass and then create 2 new materials. You want to call the first one, you want to call glass. The second one you can call like top slash bottom or something. Okay. If you hit Shift H, you can hide everything except your selection, in our case the hourglass. You want to go to side view, go into edit mode, and in face select mode you want to go to wireframe mode. Select the middle part of your hourglass and then assign the glass material. Now you hit Control I to invert your selection, and then you go to the bottom material, to top and bottom, and you hit Assign. Okay, great. Now if we go into render mode, and we actually, for this, we can enable the default Blender HDRI again. So disable scene lights and scene world in this tab right here. Okay, so for the glass material, you want to lower the roughness. Let's amp up the transmission. So now we can like, if you enable the plane, you can see your sand. I mean, you should see your sand. If you can see your sand, make sure that you like click on the plane and go into your geometry nodes and just make sure that everything is working here, and that your sand collection is disabled, because if you have it enabled, you will have the particles like twice in your scene in a way. So just make sure that you can see them, like the collection. Okay. So for the glass of the hourglass, you want to play around with the IOR, with the index of refraction. So if I put this to 1, you can see that now everything is really clear. Like, it's almost as if there's no glass, right? You can just see through it without any trouble. But what we want some distortion on the edge. So I'm just gonna hit Shift to make really small changes to this value. And I'm just gonna amp this up let's take this to 0.7 something. So 107 is the number I'm using now. Okay. Now, furthermore, I want to play around with the roughness of this glass material. So I'm just gonna switch this window to be the shader editor. And now, if I introduce a Fresnel node to this, Fresnel, and I preview this in the, if I preview this, you can see what a Fresnel node does. It basically introduces like a rim around your object, and we can use that to drive our roughness. So if I put this into the roughness and I connect this again, you can see now we have this nice like edge around our like glass part of the hourglass. And you can play around with the IRR until you get something you like. This is also like depending on how you view it, like the angle you view it from. Yeah, but I think this works. Okay, let's move on. Let's play with the top and bottom material for this hourglass. For this, it's really simple. I'm just gonna take the base color and I'm just gonna make it like yellowish, something like that. This works. Okay, so for the sand material, we actually have to go, like you click on the plane, and remember, right now we have the geometry nodes and then we have our remesh, right? The problem is if you would try to apply the material here in this geometry node stack, it wouldn't work because the remesh is coming after that stack, and the remesh is basically removing any material on your object. So what we have to do, we have to create a new geometry nodes modifier, which is here. And in that one, we can just call this a sand material. And that one, we can actually geometry node editor, that's right. And we will use the set we will use the set material node. First of all, just select your plane and create a new material. You can call this sand emission material. And now we can, like in this new geometry nodes tree, we can select this material. So in my case, it's sand emission material. And now we actually can see it and it works. So we can just play around with the emission now. Like for example, if I put this to pure white, you can see this works. Okay, so let's switch back to the shader editor now. And we will use the Fresnel node again. So just search for Fresnel. And if I, again, remember, if I plug this in, you can see that we have this nice rim lighting here again. And we can use that to get some interesting material going. Basically, you want to, between your Fresnel node and your principled BSCF, you want to add in a color ramp. And now you can actually play around with the color of this. So the one color should be blue, like the inner one. And the outer one should be like yellowish. Okay, and now we can just put these together, like the handles, to get some contrast going. And you really need to, like, if you can't see anything, like in my case, you have to play around with the IRR until you can, like, there's a point where here, right there. So now I have this like blue material in the middle, And then I have this yellow glow on the outer part of the sand, which looks pretty interesting in my opinion. Okay, great. So the last thing that we need a material for is the particles, right? And that's really easy. You just go to the particle that you instanced on your particle system, and you give that a new material, and you can call that particle, and you just make it like pure white, right? Like just emission strength 1, emission color white, and now you have some nice lighting in your scene. Okay, great. For the lighting, like I said, you put this to pure black, like the world color, and like actually I'm gonna switch now to the original scene lighting. So I go up here and I enable scene lights and scene world. So now we actually can see how it looks. And now you want to add in an area light like this, and you put that above your hourglass. It should come slightly from the back, and just rotate this a little bit like this. Put it up. Just give this light the blue color that you also used for the sand, okay? And then just amp up the strength to maybe like 2000, so it looks something like this. Okay, great. You might find that when you play your animation, it can be that your rigid body simulation is actually intersecting with the top of your hourglass, or any part of your hourglass really. And an easy way to fix that is just to select the problematic area. For example, it's the top part. So what I do is just I select everything, and like this, and I extrude it up by 0.05 for the top part, and on the bottom part I do the same by minus 0.05, because we go in the other direction. So if you find anything like that, just extrude the face where you have the problem, and you will be fine. Another really handy shortcut, by the way, if this happens here, for example, on something like, let's say the intersection happens here, you can always just say Alt E and say extrude along normal, and now you can extrude it like that way as well. So if you hit like maybe like this angle, and if you hit Control Alt and then a 0 on your numpad, you can change the location of your camera. And if we go to the camera settings and put this type to the type to be orthographic, you can see we now get this kind of like, yeah, orthographic view. And if we play around with the orthographic scale, we now can really decide how we want to frame this. Also, go to the output and change the resolution to be 1080, and the Y to be 1350. So we have our Instagram dimensions. Okay, in your viewport, hit N and go to view, and then click camera to view, so you can now so your camera will basically follow your like mouse in a way. Like if you drag and everything, it will follow. So you really can decide what framing you want more easily. And now I can see that my particles, they are way too, like they should be more in the center. So I'm just gonna click on my particle system, and I just scale it down like this, and I play this again. So finally I go to compositing and I hit use nodes. And basically what we do, we first of all, let's go to the render settings and put the max samples to be 1. and also disable denoise. Actually enable denoise and put this to GPU compute. And if we now render one frame, we can use this frame to play around with it in the compositing tab. So if we bring in a scale node and we scale this down to be 0.1, and then we pixelate it, so bring in the pixelate node, which I guess pixelates the picture, and we scale it up to be like 10 times the size, we get this, right? So we get this now. What we do here, we say, okay, scale it down, pixelate it, and then we can scale it up again. So we lose a lot of quality basically on purpose to get this kind of like stylized look, right? By the way, you also want to introduce some glow effect kind of. So you can search for glow. Or like, I think it's called glare. Yeah, glare. And you put this to be streaks. You can split your view now. If you go to the right corner and you hit a vertical split, you can, and you put this to a 3D viewport, and you go to the render view. You can, up here in the right corner, you can enable the compositing, and you put that to always, right? You can see the result of the compositing right away, which is really nice. Otherwise, you can just select this to be only visible in your camera if you want that. But now we can see this is too pixelated, right? This is a little bit too much. So maybe we put this down to be not 0.1, but maybe 0.2. So like this. And now you can see we already get back some resolution, but we don't put this like to 5 and to 10, maybe to 5. And now you can see we have a little bit more detail. But we can see that our sand is really, it's not looking great. If we switch this to shader editor, we can play around with the emission strength. So let's put this to 3 maybe. So now our sand is actually like glowing, maybe like 5 even. Maybe I have to disable the denoise after all. If you disable the denoise, you really have to make sure that you have enough samples. So maybe I put 100 samples here and render this. Yeah, I think that's better. Okay, so disable the denoise, but then put the samples to a reasonable amount so your picture is not crazy distorted or something. Okay, so I think the only thing that is not cool is the top and the bottom of our hourglass. Like, it's looking really flat, and we can change that by it's not looking too great, and we can change that by playing around with the strength of our light. So maybe I put this to 5, and let's view this. Yeah, that's better. That's way better. And I think that's a good result. So I will render this now. I think this is pretty cool. Let's render this. So I will use 100 samples and GPU compute, of course. So if you want to have like a MPEG file right away, you can put the frame rate to be like, if I put this to custom, I can just put the frame rate to be like, I don't know, 21. I think that's laggy. Like it shouldn't be, it should not be like laggy, but just a little bit, you know, like it should little bit, it should stutter a little bit to have that like old like game aesthetic in a way. I mean, if you want like a OG loading animation, you can put this to like 12 frames or something, or like 6 or something, to really get this like frame by frame look. But I think 21 is pretty cool. Otherwise, I will put this to file format. Let's put this to FFmpeg video, and let's do encoding. Let's do perceptually lossless. Video codec H.264, and yeah, I think that's fine. And that's I will put it here. Loading animation tutorial. If you hit Control and then F12, you can actually render your whole animation right away. One last thing before we can actually render this out is to think about it. Like, you want to probably, I mean, this isn't a perfect loop by any means, but maybe you want to find a frame where the last and the first frame is kind of the same, because since we will use a low frame rate and you will have this like stutter laggy look, it's not even that big of a problem if you don't have a perfect loop, because the animation is laggy anyway. So you can have kind of like a jump in your animation. What I do now is, I know that our spinning is starting at frame 60. So what I'm doing now is I'm searching a frame where my hourglass is fairly in the middle of the whole thing. So if I take a look at my empty, I can see that like right now the hourglass is at the like the bottom position, and now it's going up. So somewhere here should be like the middle position, right? So I'm gonna set the start frame to be 35, and the last frame should be something where our hourglass is in the middle again, right? So maybe something like something like this. If I now skip to frame 35 and skip to frame 448, I can see there's still some sort of jump, right? So what I do is I go back even more until the position of the hourglass is kind of like matching, right? So 477. Our hourglass is a little bit too much like up. So maybe like 480 maybe. This is really a trial and error game. Yeah, I think that's fine. That's fine. We can work with that. Okay, and now you just make sure that you don't have anything in your scene that you don't want to have rendered, and you just hit Control and then F12, and now you can actually render out your animation. So that's what the animation looks like after rendering. Yeah, I think it's pretty cool. If you have any questions, just comment down below and I will try to answer them. And I'll see you guys in the next video.